Hello my friends, Ding Xiong and I will present some summary about man-made satellite. Orbit of satellite. Man-made satellites are machines made by people. ISS can be seen from the Earth because of its large size and orbits at a height of 408 km. MEASAT satellite is difficult to be seen as it is small and orbits at a height of 35,786 km. Satellites move in orbit at specific heights and suitable linear speeds. Formula for centripetal force and neutron universal law of gravitation are used to establish and determine the linear speed of satellites. Centripetal force is a force that makes a body follow a curved path. Newton's universal law of gravitation states as that every particle attracts every other particle in the universe with a force that is directly proportional to the product of their mass and inversely proportional to the square of the distance between their centers. That's what picture you can see. A satellite moving in a circular orbit around the Earth experiences centripetal force, which is gravitational force. The picture show the formula about centripetal force and between gravitational force. Good. And this picture show comparison between geostationary and non-geostationary satellites. There's the first direction of motion same as the direction of Earth motion. T equal 24 hours above the same geographical location. Communication satellite MEASAT and the same similarly between the two orbit the Earth. V equal GM square root per hour. T equal 4 pi square hour square per GM square root. And the different non-geostationary satellite is direction of motion need not to be the same as the direction of Earth rotation. T is shorter or longer than 24 hours above different geographical location. And this example Earth imaging, GPS, weather forecast, SAT, radar AST, PP, and IAS. As GM is constant, linear speed of the satellite only depends on the radius of its orbit. If a satellite is at a height above the surface area of the Earth, this was the formula. This was the formula. Man-made satellite can be launched to keep orbiting at specific heights around the Earth at radius of orbit if the satellite is given linear speed. This is the formula.
Geostationary and non-geostationary satellites. Geostationary satellite, special orbit named the geostationary Earth orbit, moves around the Earth in the same direction. Orbit period T equal to 24 hours, always above the same geographical location. Non-geostationary satellite, normally in a lower or higher orbit than the geostationary Earth orbit. Orbital period is shorter or longer than 24 hours above different geographical locations at different times. Escape velocity, also called V, is the minimum velocity needed by an object on the surface of the Earth. Overcome the gravitational force and escape to outer space. Object possesses gravitational potential energy. This is their formula. Distance of an object from the center of the Earth R. Mass of the object M. Mass of the Earth capital letter M. This is their formula. Benefit and implication of escape velocity. Earth is able to maintain a layer of atmosphere around it. Molecules in the atmosphere move at a average linear speed of 500 ms, lower than the escape velocity from the Earth, and molecules will not be able to escape from the Earth into outer space. Commercial aircraft of fighter jets is able to fly to high levels in the atmosphere without the possibility of escaping into outer space. Commercial aircraft can fly at linear speed of 250 ms. Fighter jets can achieve supersonic linear speed of up to 2020 ms. Their linear speeds are lower than the escape velocity from the Earth. Solving problems involving escape velocity. Escape velocity of mass is low. Gases are easier to escape to outer space, causes the density of the atmosphere on Mars to be low. Jupiter, on the other hand, has a high escape velocity. Hot gases cannot escape into outer space. Escape velocity is important. Determine how spacecrafts can land and how take off safely from a planet.
Now we have some examples for you all. The moon and the sun are two bodies in the solar system. Table 3.5 shows the values of the mass and radius of the moon and the sun. Compare the gravitational acceleration on the moon and the sun. We find out the mass and radius in the table 3.5 and using the formula G equal Gm per r square, you will get the gravitational acceleration on the moon and the sun. Second, compare escape velocity from the moon and from the sun based on data provided in table 3.5. And you need to use the formula V equal 2 gm per r square root. You will get the answer, get the escape velocity from the moon and from the sun. You will get a conclusion. The moon has low gravitational acceleration and escape velocity because the mass of the moon is smaller than that of the sun. The sun is the largest body in the solar system. Gravitational acceleration on the sun and escape velocity from the sun have the highest value compared with those of the moon as well as other planets. That's all. Thank you.